All right, I'm going to go through all the parts of the Chapter 1 study guide. So if you missed something and you're not sure how to do it, this is where you need to be. All right, so if you don't already have your toolkit out, you need to get your toolkit out because you need the formula sheet to answer the following questions. The first part says, the blank is the distance around the outside of a shape. The blank is the measure of the space inside the shape. So this one's pretty self-explanatory, I hope, because right here is the words area and perimeter. So which one goes where? Pause the video and see if you can fill them in. Okay, so this is how you should have filled them in. The perimeter is the distance around the outside of the shape. The area is the measure of the space inside the shape. So let's take a look at the first shape. The first shape is kind of a little wonky. It's built of unit tiles. So the area is actually pretty simple. You're literally going to count the tiles. So this is 1, 2, 3, 4, 5, 6, 7, and 8. So the area is going to be 8 units squared. So because there's not a label like centimeters, feet, meters, we're going to use the word units. Okay, so I'm going to erase that. And then we're going to move to the outside edge. Okay, so on the outside edge, we're looking at the perimeter. So how many units around is it? So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 units going around. So the answer is going to be 18 units. Okay, hopefully that was pretty easy and pretty straightforward. Let's look at example number 2. Now for example number 2, let's start with the perimeter. Okay, the perimeter is that outside edge. So 8 plus 3, oh wait, this side here doesn't have a measurement, but it's the same as the side that's parallel to the other 8 and 3. So when I add these, I have 8 plus 3 plus 8 plus 3. So 8 plus 3 is 11, and then I'd have that same amount again. So plus 11 more gives me 22, and this one has a label, so it's centimeters. Okay, let's take a look at the area, sorry. So the area of a rectangle is length times width. So the area is 8 times 3. And that gives us 24, I'm not going to fit it in here, centimeters squared. Alright, so let's take a look at the area and the perimeter of the triangle. Let's just start with the area. If you looked up the formula on your formula sheet, you got area equals 1/2 base times height. So remember that the base and the height are always adjoined by that 90-degree symbol. So I'm going to have area equals 1/2 times 12 times 5. Half of 12 is 6, and 6 times 5 is 30. Labels inches squared. Let's take a look at the perimeter. Remember the perimeter, again, is that outside edge of our shape. So 13 plus 12 plus 5. 13 plus 12 plus 5. 13 plus 12 is 25, plus 5 gives me 30 inches. Alright, so let's take a look at the trapezoid. Let's do the perimeter first because that's less tricky. I have the outside edge. 13 plus 12 plus 13.4 plus 23. So when I add those together, I get 61 and 4/10 or 61.4 centimeters. All right, so now let's take a look at the area. The area of a trapezoid is kind of tricky, but let's just follow the formula and it'll help us out. So, the formula for a trapezoid is 1/2 times the height times base 1 plus base 2. Okay? So the height is the dotted line shown with the 90-degree symbol. So 1/2 of 12 times, the bases are the parallel sides. So you see those wonky arrows? That arrow and that arrow, that tells me those sides are parallel. That tells me those are the bases. So 12 plus 23. So we have to do order of operations. In parentheses first, 12 plus 23 is 35. So I have 1/2 of 12 times 35. 1/2 of 12 is 6, and 6 times 35 is 210 centimeters squared. All right, let's take a look at the parallelogram. The parallelogram, the area of a parallelogram, I'm going to switch colors so it doesn't blend with the one above it. Area of a parallelogram is simply base times height. So remember, the base and the height are joined by that 90-degree symbol. So the base is 7 and the height is 3. So 7 times 3 gives me 21 yards squared. Okay, so let's take a look at the perimeter. Remember, the perimeter is that outside edge. 4, well, let me switch colors here. 4 and 7. Now remember, this side's also 4 and this side's also 7. So 4 plus 7 is 11, and we have that double, so it's 22. And our label is yards. All right, so we flipped over to the other side. Looks like we're going to be doing some probability. It says there are 8 yellow, 4 orange, 6 green, 5 purple, and 2 red Skittles in the bag. So the first thing that you need to do is find out how many total Skittles there are in the bag. So when you add that up, I got 25. Hopefully you did too. So I'm going to write that at the top so I don't forget. Okay? So then the first question says, what is the probability of green? So does everyone see this P and the probability of green? So the P next to the parentheses means I want the probability of getting the green Skittle. Okay? So how many green Skittles are there? There's 6 out of 25. Now, can you simplify that fraction? You can't, because 5 goes into 25 but not 6. So now let's look at part B. It says, what is the probability of not purple? So think about that for a second. What does that mean? Not purple means I'm going to get yellow, orange, green, and red. So what is 8 plus 4? That's 12. Plus 6 is 18. Plus 2 red Skittles gives me 20. Okay? So I have 20 out of 25. Now that one can be reduced. 5 goes into both the numerator and the denominator. So 20 divided by 5 is 4, and 25 divided by 5 is 5. Okay, so the last one. The probability of orange or yellow. So that means getting orange and yellow together. The word or means I'm adding. So 8 plus 4 gives me how much? 12 out of 25. Now again, the only number that goes into 25 evenly is 5, and that doesn't go into 12, so it can't be simplified. So your answer is 12/25. The rest of the questions. Number 2, did you just find theoretical or experimental probability? So did we just predict what we might get, Or did we have an experiment where we pulled a Skittle out and tracked how many times we got red, how many times we got green? The answer to this question is we just did theoretical probability. Okay, we predicted what would happen. Number 3, which color is most likely to be chosen from the bag of Skittles? So which color has the highest probability of being pulled? Hopefully you're saying yellow because yellow has the most. Which color has or is least likely to be chosen from the bag of Skittles? Well, that one would be red because there's the least amount of red Skittles. All right, let's take a look at number 5 and 6. Number 5, based on Rudy's baseball statistics, the probability that he will pitch a curveball is 1/4. So we know that 1/4 is important. If Rudy throws 20 pitches, how many pitches most likely will be curveballs? So this is a 20 times 1/4. Remember, this is really like 20 over 1. Okay, so 20 times 1 is 20, and 1 times 4 is 4. 20/4. That's not one of my answer choices. Oh, I need to simplify. 20 divided by 4 gives me 5. 5 is your answer. Let's take a look at 6. I have a penny with heads and tails, so I know I can get heads or I can get tails. If I were to flip the coin 50 times, how many times would I expect to get heads? Okay, well, if there's 2 sides on the coin, I could get heads 1/2 of the time, or I could get tails 1/2 of the time. So what is 1/2 of 50? It's 25. You would expect to get heads about 25 times. All right, we have 2 fractions where one's adding and one's subtracting, but we use the same rule because we need a common denominator for both of them. Okay, so for the first one, I have 3/5 and 1/4. So my common denominator is going to be 20. Okay, I'm going to draw a line down the middle of my page so I can separate the 2 examples. Common denominator is 20. How would I get from 4 to 20? I'm going to multiply by 5. So my numerator is also going to be multiplied by 5. Let's go to the other example. 3/5. How would I get from 5 to 20? Well, by multiplying by 4. So I'm going to multiply the numerator by 4 as well. So I get 12. When you add fractions, you keep the same denominator. And then I add the numerators. 12 plus 5 gives me 17. That's my final answer. Part B, oh wow, this one looks a lot easier because I have 5/8, and 8 is going to be my common denominator because 4 goes into 8. So guess what? That first fraction I can keep as is. The second fraction is the only one I need to change. So 4 times what gives me 8? 2. So my giant 1 is 2 over 2. 1 times 2 is 2. 5 minus 2 is 3 over 8, 3/8. The next 2 fractions in number 7 are multiplication and division. So multiplication you should be like cheering about because it's so easy. I have 3/8 times 2/3. I multiply straight across. 3 times 2 gives me 6. 8 times 3 gives me 24. Now this might be the tricky part. You need to simplify your answer. So what number can I divide 6 and 24 by? Well, if you're not sure, they're both even numbers, so start with 2. 6 divided by 2 is 3, and 24 divided by 2 is 12. But because we didn't use the highest number that goes into 6 and 24, I have to reduce again. So 3/12 can be reduced because 3 goes into both 12 and 3. So 3 divided by 3 is 1, and 12 divided by 3 is 4. 1/4 is my final answer. Could I have gotten that by starting with 6/24? Yes. So let's go back up to 6/24. let's think hard. What numbers go into 6 and 24? Well, they're going to have to be an even number because they're even. Okay, so 2 goes in, we know that. 4 doesn't go into 6, but 6 is the next number. So if I divide both by 6 over 6, I can get 1/4. Let's look at D. 7/8 divided by 1/3. So I'm going to keep the first fraction, I'm going to change division to multiplication, and I'm going to flip the second fraction. Now I have a pretty straightforward example where I am just multiplying. 7 times 3 gives me 21. 8 times 1 gives me 8. Okay, so I can simplify this. 21 divided by 8. How many times does 8 go into 21? It goes 2 full times, because 3 full times would be 24. And then how much do I have left over? So 8 times 2 gives me 16. So 21 minus 16 is 5. So my top number in my fraction is 5, and I keep the same denominator, 8. Final answer is 2 5/8. All right, only 2 problems left. Number 8. The first one says I have 0.375. Now, how would you really read that fraction? Well, you read it by the place value of the 5. So this is 375 thousandths. 375 thousandths. Okay? Yeah, I can simplify that. So let's talk about what goes into it. Well, 75 and something ending in 0, well, right away either, 25 can go in, 5 can go in, but you know what? Let's just start with 25. That's pretty easy. 375 divided by 25. So think about it. How many quarters would go into $3.75? That would give me 15. How many quarters in $10? 40. Now I can reduce with 5. 15 divided by 5 is 3, and 40 divided by 5 is 8. Now I did the hard one first, so let's go to the percent. The percent's going to be pretty easy. So, let me erase what I have here. And my decimal point is going to move 2 spots to the right. So 1, 2. It goes between the 7 and the 5. One more problem. I hope you're looking at this one and you're like, oh, this one's a little bit easier than the last one. So let's start with going from the percent to the decimal. So right now in 40%, the decimal point's behind the 0. To change it to a decimal, I move it 1, 2 spots to the left. Now, I really don't need that 0 behind it anymore, so it's 4/10 is how I would read it. So my fraction is 4/10. I can simplify that. 2 goes into both 4 and 10. 4 divided by 2 is 2. 10 divided by 2 is 5. So if you're not sure about any problem on the study guide, you can go back and rewatch the me working out the problem, or feel free to stop by my Flex today and ask me any questions.